welcome to the channel. So in today's video I want to explain gradient boosting classifier, which is another boosting algorithm in machine learning that comes with a Scikit-Learn library. And today I want to use a dataset called credit approval. You will find the dataset in the repository, GitHub repository. So let's get started and let's see how we can implement this using Scikit-Learn. So let's import record libraries. So import pandas spd, then matplotlib splt, then from Scikit-Learn preprocessing import label encoder, from Scikit-Learn dot model selection import train test state, and from Scikit-Learn dot ensemble import gradient boosting classifier, and finally from Scikit-Learn import matrix. Okay, so these are the libraries that I need for this example. So now let's load our dataset, which is called credit approval. Okay, so pd.did.csv .csv and df.head. Okay, so this is the first 5 rows of this dataset, and it has 16 columns starting from A1 to A16, and A16 is the target column. Okay, so let's first check the shape. Okay, so it has 690 rows and 16 columns. Let's check the unique values in our target column. So we can see plus and minus, these two values in the target column. So since this is called credit approval, I think it means plus means the credit will be approved and minus means it will not be approved, something like that. And also let's check the value counts. Okay, so minus is present 383 times out of 690, and plus is present 307 times. Okay, now let's perform preprocessing. So we have some categorical values here as well. So we need to process them and convert them into numeric values. Okay, let's first check div.info. So as we can see, we have 690 rows, but you can see in the first column we have 678 non-null, and this is a categorical column. Yes, so we can see BA, So there are some missing values. Okay, at first let's take care of the categorical features. So I for I df dot columns, if df dot dtypes is object. So object means categorical. So these columns have categorical features, this one, and all the other ones that we can see object is there. Okay, so A1, A4, A5, A6, so this one, then this 4 is A7, then A9, A10, A12, A13, and last one A6. So these are our categorical columns. So now we can just use the label encoder. So label encoder dot fit transform. Okay, so now we don't see P, A, or U, G, W, this kind of values. We can see 1, 0, other type of digits in those places. So now since we also have some null values, we also need to get rid of those. So now let's drop those null values. Okay, so let's just call it new df. Okay, we can now confirm the shape. So now we have 666 rows instead of 690 before dropping the null values. Okay, let's also so now we have 0 and 1 instead of plus and minus. So plus has been mapped with 0 and minus has been mapped with 1. And for the value counts, we will also have some changed outcome. So now minus or 1 is present 367 times and plus or 0 is present 299 times. And we can also confirm that there is no null values. So all of these are non-null. Okay, so now we can just separate features and classes. So we'll just ignore the last column because it contains the target. So we are ignoring this one. And for y, we'll just select that one and ignore everything else. So we can just remove this column. Okay, so now it's time to split a data set into train and test. So xtrain, xtest, y train, 𝗁test. Okay, so let's also check the length. Okay, so we have 532 samples in the train set out of 666 and 134 in the test. So now we can just apply the gradient boosting classifier algorithm. So let's just call it GBC. So it has quite a few parameters. Let's see: loss, learning rate, and estimators, max depth, random state max features. So many parameters. I will only change some of them. So let's first change learning rate. So I think by default it is 0.1. So I will use 0.5. Max depth is by default 1. We'll use 2. And estimators is by default 100. I'm using 10. And random state is by default none. I'm just providing 1. And after that, so train, xtrain and ytrain. Okay, model has been trained. Now we can check the accuracy both on the train and test set. Okay, so the accuracy on the train set is 91% and 88% on the test set. So let's plot confusion matrix. So matrix dot confusion matrix 𝗁test 𝗁bread matrix dot confusion matrix display. Okay, so test dot plot CMap and color bar false. PLT dot X label. So this will be prediction. Then Y label and the title. So ground truth and This is confusion matrix. And plt dot xtics and ytics. This is how the confusion matrix looks like. Let's first check the value counts of ytest. So 1 is present 76 times. 70 times the predictions are correct, and 0 is present 58 times. 48 times the model gave correct predictions and 10 wrong predictions. Okay, so we can also show the confusion matrix using the categorical labels. So instead of 0 and 1, we can use plus and minus. Okay, now we do not see 0 and 1 anymore, we just see plus and minus. Let's print few other metrics. So ytest and yprint. And also ROC AUC score. Okay, something is wrong. Oh, sorry, forgot to change here. Okay, so now it looks okay. So we got F1 score 0.89 or 89%, and this score is 93%. Now let's print classification report. Okay, so these are the precision recall F1 score for individual classes, and overall accuracy in the test case is 0.88 that we have seen here. So this one. Okay, so finally we can plot feature importance. So p.dataframe gpsec dot feature importances feature names in columns will be importance. Okay, so these are the importance of each feature. We have 15 out of 16 columns are features. Okay, so now let's sort them. So importance dot plot. Feature importance dot legend. Okay, so this is the plot of the feature importance. So it seems A9 is the most important feature, and it has, so this is the most important feature, and its value is so much higher than the second most important feature. So it's actually close to 0.8, and others are like less than 0.1. Okay, so this is how we can implement this particular algorithm, which is a boosting algorithm in machine learning called gradient boosting classifier. And in the internet I saw this is considered almost similar to XGBoost. So I will now test XGBoost to see if it actually is true. So let's say import XGBoost dot version. So this is the XGBoost that has been installed in my system. So I will just copy few lines here, Ctrl C. So this will be now XGB. Let's see if we get similar outcome. Okay, so I've fitted our training data to XGB. It has actually more parameters than the gradient boosting classifier that comes with Scikit-Learn. So now I want to copy just two more lines, this and this one. Okay, so this will be now XGB. Okay, so training accuracy is 90% and test accuracy is 82.8%, which is lower than this one, I think. So we got 91, 1% more than this one, and 88. So this is actually much higher than what we got using XGB from the XGBoost library. So it is actually not similar to Scikit-Learn's gradient boosting classifier, but in the internet I saw that they are in some cases, some posts, I mean some blog posts that these are almost similar implementation. One is using the library itself and other on using the Scikit-Learn gradient boosting classifier, but apparently it's not the same. Outcomes are different. Okay, so that's the end of this video. Thanks for watching.